We are Team 15 bringing to you Model Match. Our primary aim is to facilitate secure multidisciplinary collaboration in healthcare. Current solutions host datasets, but what is provided by data scientists are either research papers or at best source code. Training models or requesting code takes time and resources, and you can run into problems with dependencies, versioning, and lack of expertise. Our solution will provide trained Docker models ready to be run on local machines. Datasets will be displayed with their compatibilities, and users can upload results back onto the platform to provide feedback. The key requirements of our project are as follows: a closed system where administrators can add new users with either read permissions or read and write permissions, upload and download of datasets and train machine learning models, which are Dockerized server-side. These uploaded Docker images can be downloaded and users can test these models with the provided front end. Users themselves can then submit feedback on these models to support collaboration, and all of these requirements have now been turned into finished functionality. For our overall project structure, we have a secure login page to give access to the web app. Once in, both data scientists and clinicians can search for, upload, and download datasets and train models. The backend connects the web app to the database.
For the technical aspect, our system is hosted on Linode. We've built our front end with React and the back end with Python and Fast API. For the database, we're using Postgres and SQL Alchemy for an object relational mapping. Database schema and migrations are handled with Alembic. Each service lives in a Docker container on the Linode server and communicate over a Docker network. HTTP requests are handled with an Nginx reverse proxy. And now for a brief demonstration of how a user would upload and download trained models. Say I wanted to upload this very advanced machine learning model, which returns a prediction on an uploaded file. I would train my model and then take a pickle of the trained instance of that model class. Now our Linode server, I can log in. Once I'm logged in, I'll be taken to the datasets page where we can see we already have the HAM 10,000 dataset uploaded. If I click the plus, I can go to the model upload page. Here, I input a set of parameters to identify my model to potential users, as well as the requirements, the source code, the pickle of the trained model, and a configuration file which allows the service to dynamically import prediction functions from the uploaded model. Once uploaded, we can see it here on the model page. If I click, I can see the inputted parameters as well as a download button. Once I download it and run it, I can view the model front end at localhost. Here, I can upload a file for prediction, and we can see the response from our original model. Now, back on the original site, if I go to my dashboard, I can view my uploads and downloads and submit feedback on the model I just used. And here we see the result of that on the feedback page.
In terms of achievements and deliverables, we have a GitHub repo containing all of our source codes with a full deployment manual for both local deployment and full deployment onto Linode server. We also created a user manual for instructing new users in using our application, which is located on the project website, along with other important aspects of our project. And last but not least, we have a demo video demonstrating the entire user experience when using our application. We started the project with the goal of being able to socialize the idea of AI model testing and focusing on user-centric development. Our implemented solutions code base is highly extendable and maintainable. Our favorite experiences as a team have been solving a real problem and being the first to do so, whilst learning new technologies along the way. Thank you for listening.